In this video, we're going to look at the basics of how to attach a wheel to our DC motor. This is the next step after building an Omni wheel. We are going to be building robots that drive around the room, and then eventually we're going to attach a PS3 controller or a PS4 controller to it to drive them remotely. So most of our robots are going to have some form of DC motor attached to them. So it's a good thing to learn early on in this course. So I'm going to use these two pieces here, these two components, as our starting example before we move on to attaching the wheel to the DC motor. In your box, you're going to find these long pieces of metal that are cylindrical and have one flat side. Okay, these are axles. So there's going to be quite a few different sizes or lengths depending on what you're trying to do. But it doesn't matter which one you grab, just grab one of them for now. And it makes it a little bit easier to test this out, especially if you're with a partner. Okay, so the other thing you're going to need is this thing called a hub adapter. Okay, this hub is going to attach to the axle in a way that allows you to use this thing called a set screw and tighten it against the flat side of the axle. Okay, so I'm going to do that right there. And when you line up the hub screw or the set screw with the flat side of the axle, because they're perpendicular, they will bind, causing the axle to hold tight. And then when I rotate the axle, you'll notice that the hub moves. Okay, if I grab another one really quickly and show you without the set screw, you'll see that this one can spin and this one can't. Okay, so spinning because it's not set, and this one doesn't move. Okay, so that concept of using a set screw against the flat surface is very important when you're dealing with wheels or servos, anything that has a rotational movement. You want to make sure that's nice and tight so that you don't have any slippage. Okay, so I'll put that back in the box for now, and we're going to move on to the DC motor. One thing I should note is that the axle diameter of these axles is quite a bit smaller than the axle diameter of the DC motor. What that means is that you're going to have to find a hub adapter that has the proper diameter to fit on the DC motor. Those small ones will not fit on the DC motor, and one of the easiest things to do is just pick up a few, try them, and you'll notice like there's no way that's going to fit on there. Okay, so you're going to have to find your actual DC motor adapters. And we're going to place it here about in the middle of the length. We're going to line up our set screw with the flat side of the axle, take our hex key, and tighten it on. Okay, about a quarter to a half of a turn will be enough. I'll tighten it on there for the purposes of what we're doing. We then take our DC motor wheel, our big wheel, and there's a few different types of wheels in the back closet you can use in future lessons. We're going to place it over and then line it up on the front side just like the Omni wheel and go through the wheel with our screw, tighten it up with our hex driver, and then do the same thing on the other side. Notice again I'm palming or pivoting the pivot on my finger or palm. I find it a little easier for these videos to do it with my finger and just rotate with my other fingers. Okay, it lets you get that in there nice and fast. And that's the attachment, that's all. So if I pop this wheel off quickly, we're going to have to look at a way to actually attach this wheel to our robot. Okay, it's one thing to get the wheel attached to the motor, it's another thing to get the whole motor assembly attached to the robot. So I'm going to pop off this wheel so it's out of our way. I can leave the adapter on, the hub axle adapter. That's not in our way for this video. Okay, so this piece of metal here is an aluminum extrusion that allows one side to be tightened up nice and tight, and this other side almost works like a vise or a clamp. So as I tighten this, the space here, this opening, shrinks, allowing it to nicely tighten in on the motor. On the motor itself, this down here is our gearbox. It has a nice strong casing on the outside, and that's where we're going to attach to this motor mount. So I already have it attached, okay, to a long piece of extrusion for this video, but you could attach it to a channel or any other component as well, as long as you find appropriate screw spacing. You are going to need the longer of these two screws. So you'll notice that these hex screws have an axle, a nice flat pivot, and then they have their threading. You're going to need the longer of the two for this space right here. So then we're going to take it, we're going to pop it through. Okay, and the nice thing about these DC motors is they're asymmetrical, so depending on your application you can actually rotate it in the motor mount, and that will change the distance from the axle to your ground. Okay, so depending on your need, you may need the wheel lowered or you may need the wheel a little higher. Okay, so you can rotate it to whatever fits your needs. I'm just going to center it here so that I have maximum clearance between the bottom of my motor mount and the ground. So you can imagine if the wheel's there, it's going to increase the space here. Okay, so once I have it on, I'm going to make sure this side here on the full aluminum side is nice and tight. Okay, again, pivoting the screw, the hex driver, and just keeping a finger on that nut. And then over here on this side, the side that binds, I'm going to tighten it up until the motor doesn't really rotate anymore, and I'm going to give it a half turn. Okay, that locks the motor in nice and tight. So now when we apply voltage through our controller in a future video for coding, this motor won't spin in the mount, and all of the rotational force generated by the DC motor will go through this axle and be applied to the wheel, which will cause the robot to move forward or back. Okay, so that's the DC motor and wheel really quickly as a quick overview. I'd recommend trying this out, and then once you have it built, take it apart.